Hello everyone, and a warm welcome to today's presentation. I'm Dinesh Kumar, and I'm excited to share this session with you. This is part II of our ongoing series, continuing from where we left off. Today, we'll be exploring some important concepts that build on our previous discussions. We'll briefly cover the key topics, insights, and takeaways you can expect to gain. So, let's get started and make this session both engaging and insightful. Let's take a closer look at the paddle method, which is a modification of the USB Type 2 paddle technique. The paddle used here typically measures around 25 millimeters, with a tolerance of plus or minus 2 millimeters. This setup is designed to simulate the conditions under which a transdermal patch would release its drug in vivo. In this method, the transdermal patch is placed either between a glass disc and an inert PTFE mesh or directly onto a stainless steel mesh. Once the patch is positioned, the entire assembly is placed at the bottom of the vessel, with the mesh facing upwards, and then subjected to rotation. This ensures uniform exposure and mimics the movement that would occur in the body. The paddle is positioned over the disc, which is key for maintaining consistent agitation. This setup is part of the USB Apparatus Type 5, which is specifically designed for testing transdermal formulations. Overall, this method provides a controlled environment to evaluate how the patch releases the drug, giving us insights into its performance in real-world conditions. It's a crucial part of ensuring the quality and efficacy of transdermal products. Now, let's take a closer look at the rotating cylinder, which is a key component of USB Apparatus Type 6. This apparatus is specifically designed to simulate the agitation and mixing processes that occur in pharmaceutical manufacturing. The rotating cylinder essentially functions as a vessel that rotates around its axis, providing a controlled environment for testing dissolution. It's important because it helps us understand how a drug will release in the body under standardized conditions. When we talk about USB Apparatus Type 6, we're emphasizing its unique design that allows for consistent and reproducible results, making it a critical tool in quality control and formulation development. This setup ensures that the dissolution process is uniform, which is vital for assessing the bioavailability of oral dosage forms. Overall, the rotating cylinder is a fundamental element in ensuring our products meet strict regulatory standards and perform reliably in real-world conditions. Now, let's take a closer look at the reciprocating holder method and its applications. This technique is particularly useful for testing extended-release tablets, which require careful evaluation of their dissolution characteristics over time. It's also commonly used with transdermal patches, where maintaining consistent contact and movement is key to simulating real-world conditions. In terms of equipment, you'll often see the USB Apparatus Type 7, also known as the flat-bottom vessel. This setup provides a stable environment for testing, especially when combined with the reciprocating holder. The vessel's flat-bottom design helps ensure uniform contact with the patch or tablet being tested. The core idea here is that the reciprocating holder moves the sample in a controlled, back-and-forth motion within the dissolution media. This dynamic action better mimics physiological conditions, particularly for transdermal patches, where movement influences drug release. Overall, this method enhances the accuracy and reproducibility of dissolution testing, which is critical for evaluating the performance of these delivery systems in a way that reflects real-world use. Now, let's take a look at the reciprocating holder method, which is utilized with the USB Apparatus Type 7. This method involves a reciprocating motion, meaning the holder moves back and forth in a controlled manner. It's particularly useful for certain types of dissolution testing, where this kind of movement helps simulate the actual conditions a dosage form might encounter. The USB Apparatus Type 7 is specifically designed to perform these tests efficiently and accurately. It's important because it ensures consistency and reproducibility in our dissolution results, which are critical for quality control. By understanding this method and equipment, we can better appreciate how dissolution testing mimics real-world conditions, ultimately helping us ensure the efficacy and safety of pharmaceutical products. This ties into our broader goal of maintaining high standards in drug testing and quality assurance. Let's take a closer look at the USB apparatus Type 7. This specific apparatus is designed to simulate the dissolution process in a controlled environment. It's particularly useful for testing solid drugs in a way that closely mimics how they behave in the human body. The Type 7 setup usually involves a specific vessel shape and agitation mechanism that ensures uniform mixing. This helps us gather more accurate and reproducible data on how a drug dissolves. Understanding the different USB apparatus types, like Type 7, is crucial because each one serves a unique purpose depending on the formulation we're testing. Using the correct apparatus helps ensure our results are reliable, which is essential for quality control and regulatory compliance. In the context of our overall presentation, recognizing the features and applications of Type 7 enhances our ability to select the right testing method for various formulations. This ultimately supports our goal of ensuring consistent, safe, and effective pharmaceutical products. All right, let's take a closer look at the parts of the dissolution apparatus. This equipment is essential for testing how quickly a drug dissolves, which is a key factor in its bioavailability. When we talk about its parts, we're really focusing on the components that work together to simulate the conditions in the human body. First, there's the vessel, which holds the dissolution medium, usually a liquid that mimics bodily fluids. It's important because it provides the environment where the tablet or capsule interacts. Then, we have the paddle or basket, depending on the type of apparatus. These are the mechanical parts that stir or agitate the medium, ensuring uniformity and proper contact with the drug. Next, the drive mechanism powers the paddle or basket, making sure the movement is consistent and controlled. Temperature control is also crucial, usually maintained at 37 degrees Celsius, to replicate body temperature. This is achieved through a heating element and thermostat. Finally, the sampling system allows us to withdraw samples at specific intervals, so we can analyze how much of the drug has dissolved over time. Understanding each part and how they work together helps us ensure the accuracy and reliability of our dissolution testing, which ultimately supports the quality and efficacy of the pharmaceutical product. Let's take a closer look at the main parts of a dissolution apparatus, starting with the jar lid, which not only seals the vessel, but also often incorporates biometric login features to ensure security and proper access. Moving on, the stirring element, which can be a paddle or a basket, is essential for agitating the sample and ensuring uniform dissolution. The water bath surrounds the vessel, maintaining a consistent temperature during the process. The circulation tube is responsible for circulating water or other fluids to help keep the temperature stable. The delight indicator provides visual cues about the operation's status, while the temperature controller allows precise regulation of the water bath temperature. The hexagonal vessels, or hexavessels, hold the samples and are designed for optimal performance. The vessel top plate helps secure the vessels and provides stability. For documentation and record keeping, there's a thermal printer that prints out results or logs. The touchscreen display is the user interface, making it easy to control and monitor the entire apparatus. All these parts work together to ensure accurate, reliable dissolution testing, which is fundamental in quality control processes. And of course, the trusty 8 Gen 2 basic system integrates these components seamlessly for efficient operation. Let's take a closer look at the key parts of the dissolution apparatus. First, we have the Delight technology, which is essential for precise control and monitoring during testing. Next is the sample collector tray, where the samples are collected after dissolution. The sample collector arm works in tandem with the tray to position samples accurately. The DX sample collector is specifically designed for dependable sample retrieval, ensuring consistency. Moving on, the syringe pump is a critical component that controls the flow of liquids during the process, providing accurate dosing and transfer. The cannula and temperature probe are vital for maintaining and monitoring the correct temperature, which is crucial for reproducible results. The auto dispenser plate automates the dispensing of samples, saving time and reducing manual error. The syringe manifold connects multiple syringes, allowing for efficient handling of multiple samples simultaneously. Finally, we see the trusty 8 Gen 1 system paired with the DX Auto Sampler, highlighting the integration of advanced automation to streamline the entire dissolution testing process. Understanding these components helps us appreciate how this equipment ensures reliable and consistent results in our work. Now, let's talk about some good practices from a compliance point of view. These are essential to ensure that we're not only following the rules, but also fostering a culture of integrity and accountability. First, always stay informed about the latest regulations and standards relevant to your area. Being proactive helps us avoid unintentional violations. Second, maintain thorough documentation of all compliance-related activities. Clear records can be invaluable if questions or audits arise. Third, promote open communication within your team. Encourage everyone to speak up about concerns or potential issues. Transparency is key. Fourth, implement regular training and awareness programs to keep everyone up to date and engaged. Lastly, establish clear policies and procedures that are easy to understand and accessible. These practices help us embed compliance into our everyday operations, reinforcing our overall commitment to ethical standards. Let's now discuss the key practices from a compliance perspective when starting a dissolution run. First, selecting the right apparatus is crucial. It needs to be suitable for the specific dissolution method we're using. Next, the water bath must be properly calibrated and maintained to ensure consistent temperature control throughout the process. Compatibility of filters is also important. They should be compatible with the medium and not interfere with the dissolution or analysis. When working with medium volumes, accuracy is essential, so carefully measure and handle the media to ensure reproducibility. Observations during the run can provide valuable insights. Monitoring for any deviations or anomalies helps maintain quality. Sampling should be done systematically, at predetermined intervals, to accurately track the dissolution profile. Data integrity is a critical aspect. Ensure all data is recorded properly, securely stored, and traceable to support compliance and regulatory requirements. By following these steps diligently, we can ensure our dissolution testing remains reliable, compliant, and reflective of real-world performance. Let's start with checking the temperature. The key question here is whether to do it at the first or the last vessel, as this can impact the consistency of your results. Next, it's essential to perform a physical inspection of your tablet, capsule, or pellets. Look for any visible defects or signs of damage that could affect dissolution. Then, we move on to measuring the individual weight of each tablet or capsule. This step ensures uniformity, which is critical for accurate dissolution testing. Before introducing your sample, consider stirring the media thoroughly. This helps ensure the media is uniform and well mixed, avoiding any inconsistencies. Now, a common question arises. Should you start the test immediately after sample introduction? Often, there's a rotation delay, which is the time you wait before beginning the rotation to allow the sample to stabilize in the media. Finally, let's review the basic steps to start a dissolution run. First, prepare your vessel and media, check the temperature, inspect your samples, weigh them precisely, stir the media if needed, introduce the sample carefully, and then start the rotation as per your protocol. Keeping these steps clear and consistent is key to reliable and repeatable results. Once the rotation delay timer finishes, the test is automatically initiated, and the system records the exact time in the test report for accurate documentation. Then, the dosage form is introduced into the vessel, which triggers the start of the rotation delay timer. At the same time, the drop sync timer begins counting down, and I place the tablets onto the dispenser plate, ensuring everything is synchronized for precise dispensing. As the process continues, the system works to attain the set temperature in all vessels, which is crucial for consistency and quality control. This entire sequence is managed by our Auto Drop Sync TM, which ensures that the timing and synchronization are maintained throughout, ultimately helping us achieve reliable and repeatable test results. Let's move on to slide 14, which covers the USB Chap 711 regarding baskets. First, cleanliness is crucial, as it ensures that the baskets do not introduce any contamination or compromise the quality of the product. Next, we have basket mesh integrity. It's important that the mesh remains intact, with no tears or damage, to prevent debris from escaping and to maintain proper filtration. Then, we look at basket dimensions. These need to be precise to fit correctly within the apparatus and ensure consistent results. We also have the basket holder, which should feature a secure clip and an O-ring. This setup helps keep the basket firmly in place during operation, reducing any risk of movement that could affect the testing process. Overall, paying close attention to these aspects, cleanliness, mesh integrity, dimensions, and secure holding, ensures the reliability and accuracy of our testing process. These elements are fundamental to maintaining quality and consistency in our procedures. Let's take a closer look at the apparatus, specifically the baskets. Baskets are a crucial component in our setup because they serve as containers that hold and organize various samples or materials. Their design and material are important because they need to be durable and resistant to the conditions they're exposed to during the process. The key point here is that baskets help us ensure consistency and efficiency. By having standardized containers, we can easily handle multiple samples, reduce contamination risks, and streamline the overall workflow. It's also worth noting that the design of these baskets can influence how well they perform. For example, some may have perforations to facilitate fluid exchange, while others are solid for containment purposes. Connecting this to the broader theme of the presentation, the apparatus, especially the baskets, highlights how thoughtful design and proper organization are essential for accurate, reliable results. It's all about creating an environment that supports precision and repeatability in our processes. Let's take a closer look at the go-no-go gauge and the mesh integrity microscope. These are essential tools for ensuring quality and consistency in our processes. The go-no-go gauge is a simple yet effective device that helps us quickly determine whether a part meets the specified dimensions. If it fits, it passes. If not, it fails. It's a straightforward way to maintain standards without extensive measurement. Next, we have the mesh integrity microscope. This tool allows us to examine the mesh at a microscopic level, ensuring its integrity and detecting any damage or irregularities that could compromise performance. It's especially important for verifying that the mesh remains within acceptable quality parameters. Now, moving on to the apparatus, specifically the basket dimensions. This refers to the size and shape of the basket used during testing or manufacturing. Accurate basket dimensions are vital because they influence how samples are held and tested, ensuring consistent results across different batches. When we talk about these dimensions, we're emphasizing the importance of precision in our setup, which directly impacts the reliability of our quality assessments. Connecting all these points to the overall theme, these tools and measurements are integral to maintaining high standards and ensuring that every component we produce or test performs as expected. They help us identify issues early and uphold the quality you expect from us. Now, let's move on to slide 17, which focuses on the apparatus basket mesh integrity. This is a crucial aspect because the basket mesh plays a vital role in the overall safety and effectiveness of our system. Ensuring the integrity of the basket mesh means regularly inspecting for any signs of wear, tears, or deformation that could compromise its function. A compromised mesh could lead to issues such as debris escaping or the basket failing under load, which could pose safety risks. So, our key points here are about thorough inspection routines and understanding what to look for when assessing the basket mesh. Remember, maintaining the mesh integrity is not just about safety. It also ensures the longevity and reliable performance of our apparatus. This ties into the overall theme of quality control and safety assurance in our operations. By staying vigilant with these inspections, we help prevent potential failures and keep everything running smoothly. Now, let's move on to slide 18, which focuses on the apparatus and basket mesh integrity. This is a crucial part of our testing process because the integrity of the basket mesh directly impacts the accuracy and reliability of our results. If the mesh is compromised or damaged, it could lead to false readings or inconsistent data. So, when we talk about basket mesh integrity, we're really referring to the condition of the mesh material that holds the test specimen. It's important that the mesh remains intact and properly secured throughout the testing process. Any tears, deformations, or looseness could allow the specimen to escape or cause uneven stress distribution. Regular inspections are key here. We need to check for any signs of wear or damage before and after tests. This helps us ensure that the apparatus is functioning as intended and that our data remains valid. Remember, the overall goal is to maintain consistent conditions for every test. The basket mesh acts as a sort of gatekeeper, so its integrity is fundamental to the accuracy of our measurements and the safety of the operation. In summary, keeping the basket mesh in top shape isn't just about equipment maintenance. It's about ensuring the credibility of our entire testing process. Now, let's move on to slide 19, which focuses on the basket attachment and removal tool. This is an essential component of our apparatus, as it allows us to securely attach and detach the basket from the main device. The key points here are the design features that make this process efficient and safe. The tool is specifically engineered to facilitate quick attachment and removal, minimizing downtime during operations. It also ensures a firm grip, reducing the risk of accidents or slippage. Connecting this to our overall theme, having a reliable and easy-to-use attachment system is crucial for maintaining safety and efficiency in our procedures. So, understanding how this tool works and its importance helps us appreciate the attention to detail that goes into our equipment design.